Hey everybody, we're here doing some half-life problems. We're doing some decay as we are talking about exponentials. So this is the equation that I have written here. Now there's variations of it, of course, but just so you can kind of see what is happening, our f of x, which is our function that tells us what our amount that remains left of whatever it is that we're talking about is, and then we have a, which is our initial amount. That's always our starting value. And we are having a half here. This is a half because it's a half-life. So we're basically having everything. So it's always going to be 50% of its previous value. And then you can see x is always in time, which is the exponent. But in this case, when we're talking about this, we are using whatever information is given to us for the half-life problem. So we're going to take a look at this problem right here. We have arsenic 74, which is used to locate brain tumors. And so we are looking at what the half-life is. So we're told that the half-life is 17.5 days. So we're going to look at a few of the different pieces of information here. So when we're looking at this equation right here, it's really important that we are paying attention to all of the pieces and where they go. So we have a couple of other pieces of information here. So we're asked, what is the decay factor? What's the length of the half-life? Write the equation for it. And then it says, find the amount of remaining after 6 days from a 90 milligram sample. So there's a lot to kind of take in here. So we're going to take a look and see what we've got going on. So the arsenic 74 is just the name of it. So that the 74 has nothing to do number-wise with any of it. So we're going to take a look at what we've got here. We have a half-life here. It tells us our half-life is 17.5 days. So the length of our half-life is 17.5 for that. Now, our decay factor is simply the half. So we always have a half for these because it's a half-life. And then we're going to look at our equation, so how we would write it. So again, we're just basically plugging in this equation with the pieces of information we're given. So we will start with f of x. And again, you might use other forms, but we're going to use f of x here. And then we're starting off with our initial amount, which you can see right here. And this is 90 milligram sample. So that's going to go right here. We have our half-life. So 1/2 will be right here, or 0.5. If you want to just write that, that's also fine. And then our fraction. So again, our fraction is going to be x over the half-life. So again, as I said, the time is our x, and then we have our half-life value. So our time here is 6 days. So we're going to put the fraction is going to be 6 over, and we have to see what our half-life time is, which in this case is 17.5 days. So that's what it's telling me, and it says half-life of. So that's what helps to decide what we're doing here. And so now this is 17.5. So now all I gotta do is just throw everything in a calculator, and we're gonna put that in there. So we're gonna start off with our initial value of 90. So we'll do 90 on here. This is just my calculator that I have at home. Feel free to use this type of calculator. It's in my showcase. And then we're going to multiply that by our growth factor, in this case actually a decay factor of 0.5. I'm just using a decimal here. Now, while this parentheses is open still, I'm going to actually put another set of parentheses in here because I have a fraction that I want to put in. 6 divided by, oops, I didn't hit the exponent button. It would help if I did that. So 90 times, and you can put this 0.5. We're going to hit this button right here. This is the exponent button. We're going to put another parentheses, and we're going to put that 6 divided by 17.5. Of course, you can always do this individually if you need. That's what I get when I do 6 divided by 17.5. And then I'm going to hit equals again, and I'm going to get my finalized answer, which is 70.96. So my answer for this problem is going to be 70.96 milligrams. And that would be how much is remaining based off of this problem. If you want more questions like these, you may find these on my Instagram, YouTube, and TikTok at YouWantAlgebra. And all of these will be located in my exponential functions section. Don't forget to like, share, and follow for more.